Welcome back to channel Mathematics lecture series. We discuss these two important functions, floor and ceiling function. Definition of the ceiling function. Ceiling function maps any real number x to the smallest integer that is greater than or equal to x. Here is the notation x. It is closed in upward just like a seal, just like a ceiling. We can also write f of x is seal of x. Here observe this interval -1 less than equal to x, x less than equal to n. From these, what is the greater than or equal to x number is n. N is a greater than from x and it is also equal to n, and this is must be a smallest integer. Means we have the n plus 1, n plus 2. So smallest one is from these all is n. So this n, this n is a ceiling function. F of x is equal to n. So f of x adopt this n, greater than or equal to x number. So this is a definition of ceiling function. Now we observe the graph of the function. This is a graph of the ceiling function. Here is a point 0. Here is a point 1. So what is the greater than or equal to number is 1. So function has ceiling function has the 1. In the intervals from 0 to 1, it has the value 1. From 1 to 2, we reach the point 0, starting point, we have the 0. At the point 0.1, this function has the value 1. At the point 0.2, this function has the value 1. Till at the point 1, it has the 1. So in this way, this function adopt the values. In the interval -3 to 2, it has the -2, -2 to -1, it has the value -1, biggest one. -1 to 0, what is the biggest one is 0. From 0 to 1, it has the 1, 1 to 2 at the 2. Now we observe the limit at the integers. What is the limit at the point 0 from the left hand side? Of course 1. At the left hand side, of course, at the left hand side, when if we approach 0, here is a 0, we approach from the left hand side, it has the limit 0. So different limits, right hand limit is not equal to left hand limit. So at all integers, limit does not exist. So function is not continuous at all integers. Now we observe the non-integers. If we observe here is approximately 0.2. What is the left hand limit? What is the left? We approach from left hand side to the 0.2. Of course, it has the limit 1. From the right hand side, it is also has the limit 1. So at the point 0.2, function has the limit 1. So non-integers at the point, all non-integers limit exist and function is continuous also at non-integers. Similarly, differentiation also holds at the non-integers but not holds at the integers. Now, of course, limit x tends to 2 if we approach from two left hand sides. Left hand sides, it becomes 2. We approach 2 from the right hand side, it becomes 3. So limit does not exist. Now we observe at the non-integers, x2 point, limit x tends to 2.5. 2.5, it has function is 3, limit is 3. So function is continuous at x is equal to 2.5. So this ceiling function means closed upward, is continuous at every non-integers but discontinuous at every integer. It is discontinuous at every integers. Now contrary floor function f of x, it is closed in downward, it goes to downward, you can see it, ceiling is goes to upward. So here it gives from 0 to 1, 0 to 1, it has the value 0. Whenever we reach the point 1, it jumps and it goes to 1. From 1 to 2, it adopts value 1. At the point 2, it will goes to 2. At the from 2 to 3. So see here another point from minus 1 to 0, it has the value minus 1. Whenever we have 0, it will goes to 0. From 0 to 1, it has the value 0. Similarly, you can observe the limit. So what is the limit at the point 1? What is the limit left hand limit at the point 1 is 0. What is the limit at the point right hand limit at the 1 is 1. So different limits, limit does not exist, function is not differentiable, so function is not continuous. So you can similarly observe the, you can write it, you can write the limits at all integers and non-integers. Here 3.7 floor, 3.7 least value 3, 5.2 small value is 5. At the point 4, it has the value 4. Of course, it jump. What about the minus 2.3? It is small number minus 3, because minus 3 is the greatest integer less than equal to minus 2.3. This is the floor function goes downward, ceiling function goes upward. You tell me what is the value of 0 in floor function? Is 0. And what is the value in ceiling function at the point 0 is 1. So this is the difference at the integers. Here floor versus ceiling 2.3, so floor value is 2, ceiling value is 3. 4.2 floor value is 4 and ceiling value is 5. At the point 5, ceiling value is floor value is 5, ceiling value is also 5. You can observe all values. Thank you to watching this important lecture. From 1 to 2, it has the value 2, and from 2 to 3, it has the value 3. So here at the point 1, it has the value 1. At the point 2, it has the value 2. At the point 3, it has the value 3. So I ask, there is a question at the point 0.1, we have the interval. If we observe this interval from 0 to 1, at the point 0, it has the value